We tend to think of AI as this magical thing that just lives in the cloud. It's all just software, right? Lines of code floating around in cyberspace. But the truth is, behind every single chat response, every amazing image, there is a very real, very physical machine. And that machine is hungry. It's constantly burning power. And believe it or not, drinking water. So today, we're going to pull back that digital curtain and look at the real-world cost of AI. And it all starts with something you can actually hold in your hand. This is wild. Depending on a few factors, like where you are in the world, a simple little chat with an AI can use up about this much water. A whole bottle. Suddenly, this isn't some abstract, far-off idea anymore, is it? It's a physical footprint we can actually see and measure. Okay, so let's zoom out a bit. That one bottle of water is just for one chat. What happens when you multiply that by billions and billions of chats from users all over the world? Well, that individual cost starts to add up to a staggering demand on our planet's resources. Okay, get ready for a pretty mind-bending number. 945 terawatt hours. That's what the International Energy Agency thinks data centers are going to need every single year by 2030. And can you guess what the fastest growing piece of that pie is? Yep, it's AI. Just to put that into perspective, 945 terawatt hours isn't just some random huge number. It's about the same amount of electricity that the entire country of Japan uses in a year. We're talking about powering a major industrial nation just for our data centers, and AI is a massive part of that. And like we said, it is not just about electricity. Check this out. This is the estimated water it took to train just one model, GPT-3. 5.4 million liters. And that number is so tricky because it's not just the water used to cool the servers in the data center itself. It also includes all the water used by the power plants, sometimes miles away, that are generating the electricity to run those servers in the first place. This footprint has layers. All right, so we've established that AI has this massive thirst for resources. But where exactly is all that energy and water going? Well, the answer might actually surprise you. It's not what gets all the headlines. This really breaks it down. You've got two main things, training and inference. Training is that huge, splashy, one-time event to create a model. It's a massive power draw, and it's what you always read about in the news. But then there's inference. That's the energy used every single time you or I or anyone else sends a prompt. And for a popular AI, that daily drip, drip, drip of energy use completely dwarfs the initial training cost. It's the millions of tiny sips, not the one big gulp, that ends up being the real issue. And even when we're talking about that initial training phase, the impact isn't set in stone, not even close. You can train the exact same model, and its carbon footprint could be 100 or even 1,000 times bigger. It all depends on the choices you make. What hardware are you using? How efficient is your data center? And maybe most importantly, is your local power grid running on clean energy or on fossil fuels? Now, I know what you might be thinking. Hey, hold on, aren't computer chips getting way, way more efficient every year? And you would be 100% right. They are. But that leads us to the central paradox of this whole story. And you can see that incredible progress right here. I mean, look at this. The amount of energy it takes to process one little piece of information, what they call it token, has just plummeted over the last 10 years. We're talking about improvements that are hundreds of times better. The engineering behind this is just mind-blowing. The chips are getting so much better at their job. So, if the chips are getting so much more efficient, why is this chart going up and up so steeply? This is the paradox right here. The efficiency gains are incredible, but they are being completely swamped by an absolute explosion in demand. It's kind of like having a car that gets amazing gas mileage, but then you start driving it 24/7. We're using AI so much more that even with these super efficient chips, the total energy consumption is still on track to nearly double by 2030. And this brings the whole challenge right to the front door of the companies building all this stuff. They have these incredibly ambitious and frankly admirable environmental goals. Google is aiming for 24/7 carbon-free energy. Microsoft wants to be water positive. But then you look at their own reports, and the reality of scaling up AI means their absolute emissions and their water usage have actually gone up in recent years. It just shows how tough this problem really is. Okay, so the problem is big, it's complex, and it's growing. I get it. But it is not hopeless. This is not about stopping progress or pulling the plug on AI. It's about being smarter.
So let's get into the action playbook because there are real ways to build and use AI more responsibly. So what can we actually do? Well, there's a whole checklist of smarter choices. First, right-size the model. Don't use a giant sledgehammer of an AI for a tiny task. Second, just putting a cap on how long prompts and replies can be saves a ton of energy. Then you get into more technical stuff, like batching queries. Think of it like a carpool for data, and using slightly less precise math, which computers can do way faster. It also really matters where and when you run these models. Choosing a data center powered by clean energy is a game changer. And finally, we can all push for more transparency from the big cloud companies. And this, right here, might be the most hopeful part of the whole story. Making these smart, behind-the-scenes engineering choices can cut the emissions by a factor of 10 or even 100. And the best part? The user would never even notice a difference. It proves that you can have sustainability and a great product. You don't have to choose.
Look, AI has this incredible potential to solve some of the world's biggest problems, maybe even climate change itself. But that promise only really works if we're being totally honest about the costs. So I guess the real question for all of us is, how do we innovate responsibly? How do we make sure that the problems AI solve are always bigger than the ones it creates?